Well then, if you came for the spectacular solar imagery, you came to the right place. If you came for the most comprehensive space weather in the world, you came to the right place. We'll even show you a cosmic ray report today. That and lots more coming from the Smash News Network, least busted name in news. And welcome to space. Congratulations on realizing the channel exists. This is the past 24 hours from the SDO AIA instrument, showing ionized iron emissions in ultraviolet radiation. 171 angstroms is the wavelength. We've got more sunspots that'll get names today. We've got some activity setting in the western limb. That increases the likelihood of large flares over there. We've got some big plasma reorientations, some coronal mass ejections, and, well, all of the rest of the information that you may have come to expect from watching the channel. Compelling imagery there of the western limb. How about some compelling imagery of the eastern limb? Yeah, we've got that for you also, folks. Again, we've got a couple more sunspot groups that will get names today. And let's take a moment to look at sunspots and magnetic fields. So here is your SDO colorized magnetogram for yesterday plus today. And there is your SDO intensitygram. Most of those groups pretty stable over the past 24 hours. We do have a new group that just formed right here. That'll get a new name. That'll get a name. And there are like 2 or 3 more groups that have just risen or formed on the eastern limb. So we'll show some high-res imagery of that toward the end of the video. Let's take a moment to see what's going on croissant Earth. Yeah, Earth. It's shaped like a croissant. Stop believing NASA's lies about spherical planets. There's Mount Ibu erupting in Indonesia. It did so in an explosive fashion and produced about a 7,500 plume of volcanic ash just earlier this morning. Taupo has now continued to calm down here, so the likelihood of a big eruption at Taupo has dropped. We covered that several weeks ago. That has continued. The New Zealand under lake volcano system there. Seismic activity has ceased. Popocatépetl exploding in central Mexico, flight level 210, flight level 190 over Colombia from Nevado de Ruiz as it also explodes. Sangay exploding in Ecuador, flight level 200. Cotopaxi exploding in Ecuador, flight level 210. And Sabancaya exploding in Peru, flight level 230. That's a 23,000-foot ash plume. Please do not pole vault the caldera. That's not shtick. People are actually that dumb and need to be told not to pole vault the caldera. After all, these videos are designed for YouTube. Here's global seismicity for the past 90 days, and there was a 6 magnitude quake. That was the largest of the past 24 hours. One thing that was kind of weird about that one is it shows it at 0 kilometers estimated depth. Now, I find that a little bit odd. There is the location of that quake. That was, I'm sorry, it was a 6.2 magnitude. It came in at 2:21 Universal Time this morning. Again, look at the depth. It's listed as 0 kilometers. So, not sure what's up with that. I won't dwell on it. It's not really a concern at all. Keep in mind, folks, we do heliophysics for the sake of cosmology. And these things like seismicity reports are just a value-added service because of the market in space weather. Space weather and Earth weather, we bring them together. So we'll cite the quakes over a 5 magnitude, like this 5.5 at Chile. That came in at 16:51 yesterday afternoon. That's 16:51 Universal Time. It was a 5.5 at Chile. It's been pretty calm here. Not a lot of quakes, certainly not a lot of big quakes. Indonesia had a 5.0. That was at 0 dark 58. 2 minutes before 1 o'clock this morning. And then at 2:21, the 6.2 occurred southwest of New Zealand. Turkmenistan had a 5.1 at 4:04 this morning. And that concludes the quakes of a 5+ magnitude. So let's get back to space. And here is the past 24 hours from SDO. Now we've added 211 angstroms to the 171 wavelength. You can see some well-defined coronal holes there. More about those in a minute. First, let's talk about the radio flux, which has come up a bit as forecast, now at 160 solar flux units. And there is the contextualization of that, represented by the black line there. That is the radio flux. And we've just recently gone above the, 162? I thought it was 164. 162 is the current radio flux. And again, we're just above the breakout line there. There seems to be some serious support there at 155 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 Janskis. Janskis are just a measurement of flux density of radiation traveling through space. The radio flux is proportional to sunspot number. As you can see there, the red line is the sunspot number. The black line is the radio flux. Space Weather Enthusiast dashboard here. NOAA forecasting on Friday, late Friday, expecting the possibility of some geomagnetic storm conditions from a coronal hole high-speed stream. We might see that a little bit earlier, but hey, we're excited about the possibility that we may see some more aurora uptick on Friday night. If you have images of the aurora, share it with us on Twitter. Or you could pick Instagram. Either way, send us a direct message or just tag us in a post. You'll find us all over the internet at Smashomash if you are new to the channel and not already aware of this. So that's the Space Weather Enthusiast dashboard. There are some coronal hole high-speed streams likely on the way. Next, we'll show the past 4 hours of Earth's magnetic moment from space. And thanks for leaving a comment, Red Split Rail Fence. So this geospace magnetosphere movie depicts magnetohydrodynamic pressure. It's showing about 12 Earth diameters. Magnetohydrodynamic pressure's units are known as nanopascals. It is a geomagnetically calm condition currently around planet Earth. Here's the ground magnetic perturbations map. Earth's magnetic moment from the ground. It's modeling magnetic flux density there, which the units of are nanotesla. And in the event that we do have geomagnetic storm conditions, this will show you the most likely places to see the aurora, pipeline, railway, and power grid induction, telluric currents, etc. Next, the planetary K index here. A little bit of an uptick there, mainly caused by magnetic field orientation. That should drop back down in the next few hours here. KP3 is the current situation. The planetary K index, an average of global geomagnetism. Next, our real-time solar wind data, and it is quite calm out there at Lagrangian point 1, where the Discover spacecraft is currently measuring the real-time solar wind. Solar wind velocity currently at 383 kilometers a second. Solar wind density here right around 4.5 protons per cubic centimeter. The rest of that is pretty unremarkable, and let's move on to magnetic data. There are your GOES magnetometers. Nothing too exciting happening there at their geosynchronous near equatorial orbits. The GOES 18 did have to do some maneuvering there. That's what the arc-jet moments are. Their thrusters create plasma, which can affect the magnetometers. Next, we'll look at the heliospheric current sheet. So this is super important, and I want to draw your attention, as I did yesterday, to this area of magnetism. That is a coronal hole that is hanging out at the north heliographic pole. And you can see the way it's looking like it's trying to snap away. It's trying to kind of migrate down here into the North Pole current sheet area. And that's because it is. It is going to do that. And that is going to signal the onset of the most solar activity we'll see during the cycle. So you can expect similar levels of solar activity that we see today for the next about 18 months. We're expecting solar max in a little under a year at this point. And again, you can expect to see that magnetism leave the north heliographic pole and be replaced by south pole magnetism. Until it leaves, I probably won't be saying we're at solar maximum. So here's our line of sight field plot. Earth is right now, it's right in the first third of the North Pole oriented heliospheric current sheet. You can see that depicted there in green. Here the sun's B field is depicted in blue. And you can see that sector boundary crossing there as coronal holes of South Pole orientation set in the west. Here's a better view of that, our coronal hole line of sight field plot. And you can see a little bit of that migration happening there, that north heliographic coronal hole there moving down toward the equator. That is going to be accompanied by significant upticks in solar activity. I'll just say that. We are not at solar maximum yet. If there are channels telling you that we're at solar maximum, you may want to leave them a comment. Just tell them that, no. Anyway, let's show the past 24 hours here in SDO 211 angstroms by itself. Let's subtract the 171 angstroms from that. And there you've got a great view of those coronal holes there in SDO 211 angstroms. Interestingly enough, we do have an active region there within this southern coronal hole. That's a feature that we saw earlier during solar cycle 25 as well. We had a legit sunspot right in the middle of a coronal hole. Could be happening again. Seems like a great place to take a look at the solar chromosphere to see what's going on in between the photosphere and the corona. The chromosphere, it's where a lot of action is located. Like the Smash News Network, least busted name in news, a lot of action is located there. Speaking of action, why don't you take action and support the channel? If you see a paid sponsorship / affiliate, that is in part our Hemp Lucid affiliate. So we have recently taken on a sponsor / affiliate, Hemp Lucid. So that is what you're seeing for the paid promotion tag on the video. Make sure you enter the promo code SMASHOMASH when you're doing your Hemp Lucid shopping. The promo code SMASHOMASH. It'll save you 10%, which is nothing to sneeze at. So check that out. You can also shop via our link. Help us to increase the probability these videos will continue to exist, remain publicly visible, and free for all to view by helping the channel out and picking up your Hemp Lucid products via our link, or again by entering the promo code SMASHOMASH to save some dough on your checkout. Next, SmashoMash.com is our homepage. You're invited to visit that as well, and welcome to the DR Renaissance. You can find links to our social media. There's a permanent invite link to our Discord chat seen right there. We are also still on Patreon, believe it or not. SmashoMash.com is the homepage. You can find links to the forum and the Smash Team site and more on the homepage. Launched in 2019 in response to pathetic censorship on Facebook. Next, today's featured product is Project Management Facts, because it's either going to be expensive but good and fast, or it could be slow where it's good and cheap, or it could be fast and not good, fast and cheap but bad. So don't be in that realm. And of course, these videos coming out every day for the past pushing 6 years are certainly fast and good. They're just not cheap. So if you've got a project manager who thinks any job is going to be fast, cheap, and good, perhaps this will make a great gift for that project manager, because no job is fast, cheap, and good. Pick two. There is no fast, cheap, and good job. So we just made that. We made it into a cool looking graphic. It's available on a white and a black background there, depending on, like, if you get a transparent sticker. This is a great one for the workplace, of course, because only hack managers think that a job is going to be fast, cheap, and good. It's a great gift for a boss who doesn't know what they're doing. Or it's a great gift to wear around a boss who doesn't know what they're doing. These facts are universal facts, folks. And today's featured product on the Amazon storefront, which you can find at amazon.com/shop/smashomash, also linked below the video and on the home page. Today's featured product is Cameron's Organic Scandinavian Blend. It is whole bean. It is quite tasty. It's kind of cheap. That might look expensive, $23.38. That's for a 4-pound bag, folks. So it's quite a good deal. The packaging doesn't look as pretty as what's depicted there. However, it tastes as pretty. It's got my endorsement. And of course, smashomash.com/smashteam is the official subscription services site of the channel. So if you want to support the channel directly and get additional content, become a member of the Smash Team. There's a bronze level, which will cost you exactly $0 per month. There's a silver level, which is $2.99 a month. Gold level is $9.99 a month. There's also a gold annual paid-up subscription, which is almost like getting 4 months for free because it's got complimentary merch included. So hit us up there. Again, extra content for especially gold and silver Smash Team members at smashomash.com/smashteam. And let's get back to space. Are you spaced out? Well, you've definitely come to the right place. So here's our sunspot analysis page, part of the Integrated Space Weather Analysis Center. Again, we'll have like 2 or 3 more named sunspot groups today. One up here, north of 3319. There'll be another one here behind 3320. So expect the sunspot number to rise once again today. Not sure about the radio flux. It'll be pretty similar tomorrow as today, because we've got setting sunspots in the west. And we've got a very high likelihood of large solar flares because we've got magnetically complex enough sunspots to produce them. So that's the situation as far as that goes. And let's take a look at some sunspots here from the SDO. So here's our SDO continuum wavelength. That is the past 24 hours, and that is a lot of sunspots. If you think that is a grand solar minimum, you are berserk. I mean, you can keep chanting the same thing over and over again to your cultists, and your cultists will largely believe you because you've like hypnotized them with nonsense. Grand solar minimum, grand solar minimum, grand solar minimum. You can chant it all day. It doesn't make sunspots disappear. I mean, check out the sunspots on the western limb. Those equate to probably over 100 sunspots there based on the counting conventions. And yeah, the east side of the sun's not shutting down either. No part of the sun is shutting down. Not the far side, not the close side, not the west, not the east, nowhere. So if you've painted yourself into a corner with grand solar minimum nonsense, please come out. The paint will eventually dry, and you can move on with your life and stop attempting to gaslight your viewers on YouTube. Next, we'll move to energetic particles and solar flares. So here is the GOES proton flux. No significant spikes in that. Solar flaring has been rising. So this was in the forecast. We said the likelihood of large flares was increasing as sunspots rise and set. Sunspots, they like to make a grand entrance and a grand exit. They like to produce large flares when they are at the limbs. There might be some valid physics to explain it. Shout out to Eugene, who's still in the process of writing a paper about the statistical analysis of sunspots and, well, really solar flare longitudes, meaning how far east or west they are on the solar disk. And the background level of X-ray flux is now at like 2.3, 2.76 rather, C2.76. So The flaring has been increasing the past couple of days. There it is. And let's switch to our favorite wavelengths for flares. 94 plus 131 angstroms. Now, you might see activity happening here in both the southwest and southeast limb. Also some activity in the northwest limb. Here is the northwest limb activity. And there was a coronal mass ejection associated with those events, which we will get to momentarily. Here's the southwestern limb. You can see some flaring activity and some plasma reorientation happening down there. And don't forget the southeastern limb. That new sunspot that just rose there is looking pretty active. So I believe that is the main source of flaring for the past 24. And let's switch to our cosmic ray report. So cosmic rays are a very interesting feature in space weather. They are largely the same material as we see in the solar wind. So cosmic rays are specifically referring to matter from outside the solar system. So it's coming from interstellar space, possibly even from different galaxies. As high-energy particles move nearly at the speed of light, they are primarily hydrogen nuclei, so protons that lack an electron moving at what we call relativistic speeds pushing the speed of light. Now, those are the most abundant. Then you've got helium after that, and then, of course, you've got subatomic particles that occur in particle showers after they strike Earth's atmosphere, or even other, not just the atmosphere, but also the lithosphere, or even the biosphere. Things like you get struck by cosmic rays. These cause genetic mutations, and they cause errors in computer systems. What this image is showing here is that it's very hard to determine where a cosmic ray comes from. We only know of one point source for cosmic ray flux in the constellation of Cygnus, the star Deneb, the brightest object visible from our solar system. So when a cosmic ray comes from across the galaxy, it could take a crazy path like this, as there are a whole series of different magnetic fields that can alter its path, and you can have a cosmic ray coming from that direction that came from way over there. So that's just the way it works, as these particles are, think of them as tiny magnets. So when they pass through magnetic fields, their paths are completely scrambled, as shown by that blue path. Again, they're mostly hydrogen nuclei. There are also helium nuclei. It's like 90% hydrogen nuclei, and then the remaining 10% is like 9% helium nuclei, and then the rest is other heavier elements, things like lithium and neon and argon and so on. The heaviest ever measured was lead, although we do anticipate that all of the elements in the periodic table are present in cosmic rays. And of course, as they get lower and lower down to Earth, they're more likely to smash into something, creating isotopes and ions and secondary particle showers. They may even be involved in things like weather and climate. So they are believed by many to cause clouds to form, and they're creating ionization pathways as they blast through the atmosphere. As they reach lower and lower energies, they'll do things like steal electrons and so on, which creates ions, and those create chemical reactions, and there's lots of stuff going on with cosmic rays. Anyway, here's the cosmic ray report. This is the Uptick neutron monitor, and it's showing a tiny downtick, almost dead flat over the past 30 days. Now, you can expect to see this precipitously drop coming soon, as cosmic ray flux is inversely proportional to solar activity. So sunspot number, radio flux, those are inversely proportional to cosmic ray flux. Here's the Barentsburg neutron monitor, and that's showing almost completely flat also there at Barentsburg for the past 30 days. Next, we'll go much farther south to Greece. There is the Athens neutron monitor, a small downtick there in the past 30 days at Athens. Let's go even farther south to Mexico City, showing a small downtick, almost flat, but slightly down over the past 30 days. And last but not least, we'll show Oulu, Finland. And the great thing about Oulu is that it shows all the way back to 1965, which is fantastic. And of course, you can see the strongest sunspot cycle there since 1965 was around 1991. You can see this very, very low cosmic ray flux moment there, associated with high levels of solar activity in solar cycle 22. So that's Oulu, Finland. It's showing a slight uptick over the past 30 days, almost flat though, and headed down as far south as we can get. DOMB Antarctica, flat over the past 30 days, and DOMC Antarctica, flat over the past 30 days. Again, you can expect a large uptick in cosmic ray flux coming soon. That is just a basic fact of solar cycle progression. So let's switch here to our star chart. This is what's going on overhead in Lehigh Valley, Pennsylvania. We use skyandtelescope.org. You can see the Sun and Pleiades not too far off from each other there in the morning sky. You've also got Saturn, Jupiter, and Mercury up there. And if you're looking out around dusk, you might see great views of Mars and Venus there, right near Castor and Pollux, and also the moon approaching full phase. By the way, speaking of the moon, shout out to our viewer Gemma for sending this photograph. Sorry it took us so long to catch it or process it. There's a great image of the full moon rising over, I think it's New York. There's the full view. Thanks for that great image. And here's your solar system forecast. This is where things are today. Here's your 1 week forecast. Shout out to all you heavenly bodies. Here's where things will be on June 7th. We will have a gibbous waning moon, which brings us to coronal mass ejections. So here are yesterday's coronagraphs, and there are some CMEs there. Let me allow that to play through once more. There could be earthly directed components there, so fingers crossed for some space weather on the way. I know where that CME came from, and it may have some minor Earth-directed components. We'll show more imagery here to validate that in a minute. First, today's frames. There are an additional 37 frames from today. Please pay attention to the time and date stamps when we show data like this. And let's also look at Soho, Lasco C2 and C3. So here's this CME that may be earthly directed, at least part of it. It is mostly off to the northwest, so we don't see a legit halo there. It doesn't mean it'll completely miss Earth. Let's pause that at 2036. 2036. And I do believe there is a minor earthly directed component there, so you can expect that to arrive sometime late in the day on the 3rd. Late in the day on the 3rd of June. Could be a minor CME impact, could produce like a KP5 or 6 sort of a situation. We'll also show stereo A along with Soho Lasco C3. Let's bring this back to around that time. You can see that CME just after midnight here. Stereo A only providing a little bit of extra angle there. As you can see, it's getting very close to Earth. Only a few degrees behind Earth, orbitally speaking. So again, I expect a minor impact there. I'll say mid to late day on the 3rd. Mid to late day on June 3rd. So we've got some more custom coronagraphs for you as well. Here are our 24-hour videos. There is Soho Lasco C2 and C3, and the SDO 193 angstroms. We'll get a little closer, and how about even closer? Again, that CME came from this plasma reorientation event up here. Some of it splashed down, and some of it is headed out into the greater solar system. Most will miss Earth to the northwest. Some is likely to strike. Here's an even closer view. And let me just check on something here. I might have missed one of our coronagraphs. I did miss one of our coronagraphs. Let me just bring that up for you in a minute here. Because this is a pretty sweet coronagraph. So that shows great imagery there of this event up here in the northwest and the Soho Lasco C2 showing that ejecta making its way out. By the way, the likelihood of additional coronal mass ejections is nearly 100% moving forward. And it's time to talk about plasma filaments, which are quite significant indeed. So again, here's the 193 angstroms all by itself. So a little bit of space weather here finally jumping off after quite a lull in geo-effective space weather. So moving to plasma filaments, and it is indeed a major plasma filament here, right in the Earth-facing zone. Here's the ground-based solar observatory at Udaipur, India. And look at the density of that plasma filament there. That is indeed a major one. If that ejects and goes straight toward the Earth, that could do something like cause certain power grids to fail. So that is quite a gigantic and extremely dense plasma filament, which is why it looks so dark. There's a lot of material blocking this wavelength, 6,562.8 angstroms. That's the vibrations of the hydrogen. And yeah, lots of plasma there hanging out. So here is the past 24 hours in our composite 304 plus 193 angstroms. We've now added ionized helium to that to show additional contrast for those plasma events. And you may see a huge filament hanging out by the north heliographic polar region. That's what we call a crown prominence. It's a tiny one at the moment. You can expect to see a lot more things like this around solar maximum. Again, we're expecting like 9, maybe 10 months until we're at solar maximum. There's a great view of that filament there in the extraordinary close-up detail. Very nice. Here's this plasma reorientation and coronal mass ejection event. You can see some of that plasma brightening up the solar surface as it splashes back down toward the chromosphere. Some more of that material, again, is mostly headed to the northwest, and some of it's probably headed toward your doorstep. A great view of the northwest. We've also got this view of the southwest, as there was some activity down there. And you can see that huge plasma filament on your left of your screen there. That one needs a name. If you want to name a filament after a living person, do it on Twitter. Follow the hashtag, name that filament. Also a crown prominence there at the southern polar region. We did not produce a short close-up of that one. However, we do have the southeast. Once again, these are all 24-hour videos from SDO, the Solar Dynamics Observatory. And there's back to the full disk view. Pretty sweet. And it's about time to see what's going on right now. So here is our last couple of hours. It's about the last 2.5 hours. And it looks like there is another CME happening as we stream the video. So up here you can see some plasma moving around. I suspect more of that is ejecting, as there is very little contrast. So when a CME is directly coming toward the Earth, it's often hard to see it without looking at coronagraphs. So that could indeed be another coronal mass ejection happening while we stream the video. Fingers crossed for that. Also, it looks like there is some instability happening over here. And keep an eye on this filament, as it is quite massive indeed. And let's get to our bonus features segment. So starting out with satellite charging hazards. And we do indeed have some satellite charging hazards, some surface variety charging hazards here in the Eastern Pacific. That could cause some minor communications errors, and we actually saw some communications errors, which we'll show you here in a minute, during our meteorology segment. The GOES electron flux is just in a normal range here, nothing too remarkable going on there by the GOES 16 and GOES 18's radiographic measurements. There's the 1-year graph right in the middle part of the range there for the relativistic electrons. There's the forecast model, and NOAA expecting that downtick to happen there. I would tend to agree with that, as coronal hole high-speed streams are typically associated with a dip in the electron flux. We'll also show the vibrational frequency of the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar to distances in kilometers. There's vibrational frequency at the bridge between Earth and space. Yeah, we're zooming in to planet Earth. We take you from the closest star all the way down to the surface. So that's the raw vibrational frequency in megahertz. Here's the anomalygram depicting anomaly in megahertz from the 30-day median. It shows high-frequency anomalies in blue and low-frequency anomalies in red, and it also shows 10 times the resolution there as it goes down to 1/10 of a megahertz. Ionosphere is looking pretty normal to me, and if you disagree, please leave us a comment and tell us all about it. Here's the latest image. That's 11:30 Universal Time ionogram and 11:30 Universal Time anomalygram. Sorry, no harbingers of the apocalypse showing up in the ionosphere. We'll also show the total electron content, which is the free electrons all the way out to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with distances in miles. These are the most likely places to see GPS errors. By the way, they do become a little bit more common during coronal hole high-speed streams. And we do see some quite anomalous areas of electron content here. So we're seeing some high electron contents, for example, over northeastern Russia, also over northern Canada, also places like the South Atlantic and southern Indian Ocean there, seeing some sort of out-of-place total electron contents. And let's zoom in on North America here as we get closer and closer to the U.S. weather portion of the video. So there we've got some significant high electron content anomalies. You can see them up the Eastern Pacific, some right on the west coast, or otherwise known as the left coast of the U.S. That may have some predictive value. We won't get into it too much as we don't want the video to be too lengthy. Keep in mind, once again, just to reiterate, we create these videos primarily for the sake of cosmology and the advancement of human technology. Perhaps in the future, we will be more concerned about doing things like attempting to forecast earthquakes based on space weather parameters. But that's what's going on. That is the total electron content anomaly from the 10-day average. And you can see, indeed, some high electron count anomalies there. Also over southern Mexico, the Caribbean. Even parts of Alaska there showing some high electron content anomalies. Does it mean the sun causes earthquakes? Not necessarily. Remember, folks, we try not to confuse people and suggest that correlation equals causation. Because if there's no physics explanation, we are out of the space weather station. So here's the latest intensitygram and latest STO magnetogram. There's the refresh. There's the other refresh. Here's the rock back. And again, we're going to have some new sunspot groups named, like this one right here. Also, this one here. And probably that one will be a new named group. I'm not even sure if that one has a name yet. So anyway, expect the sunspot number to rise today. Let's see if we can get a look at the magnetic fields of this group. Well, it's certainly beta gamma class. Let's see. This group down here is beta gamma delta class. This group here is beta gamma delta class. These groups up here are beta gamma class. There might be some minor deltas in there also. This group down here is, I think that one's just beta gamma class. So again, the propensity for large flares is certainly there. My number one spot for a large flare at the moment is this group right here. Second most likely place for a large flare is up here. And the third place would be in this area. So those are the most likely groups for large flares according to magnetic field complexity and proximity to the limb. And let's get to our meteorology segment. So we're starting out by doing some wave chasing. You may think that the world's largest waves are in the Southern Ocean, and they often are. There are some 29.6 footers over there, some 27 footers over here. However, the best surf is near Taiwan. Slightly bigger waves right there. 31.9 footers. Hey, Taiwan, once again, the surf is up. That is our significant wave height. Depicted by the color shading, the animation there is winds, surface winds. So that system just loitering there east of Taiwan. Anyway, let's get to our regularly scheduled meteorology portion of the video. These are the surface winds of the east. These are the jet streams. Jet streams of the west, depicted here. And once again, completely incoherent jet streams over the U.S. Check it out. The jet streams are like the jet streams are like PU. The U.S. just stinks. You can see a divergence in the jet stream happening around the Rockies, and then a convergence of the jet streams happening in the North Atlantic, as if the jet streams are just avoiding the U.S. Anyway, when that happens, you can expect to see weird weather patterns. It's not HARP. It's not chemtrails. It's not weather modification. It's the jet stream not moving systems in a normal fashion from west to east. Here are the surface winds of this side of the planet. Here are the surface winds of the central world. And here are the jet streams of Central Asia, Africa, and Europe. Now we have brought up sea surface temperatures here. There are your sea surface temperatures. And let's take a look at what's going on in terms of clouds and fog. Now you may see some rapid motion happening here. That's not an actual acceleration. That is missing data on the feed. And all the GOES satellites had some missing data here. So there must have been some charging hazards that happened in the past few hours, as we've got some oddities happening there indeed. I mean, it's really only the last few frames that are going to be relevant. There are the past 10 frames. You can see it's all over the place. It's showing a lot longer time frame than it normally would. So let's move on to our weather.gov map. There is your weather warning situation. What do we have there west of Lake Michigan? Looks like wind advisories over there. Head to weather.gov if you've got a weather alert in your location. And let's show some forecasts. So let's see if the jet stream returns. Here is the 250 millibar winds, which do represent the jet stream. And it looks like for the next 72 hours, the jet stream is going to continue to largely avoid the U.S. In other words, the incoherent jet stream I talked about earlier is expected to continue based on the GFS model. Next, pressure and precipitation for the next 72 hours based on the same model, the GFS. That is where we are expecting precipitation to fall and some strong storms coming once again to north-central Texas, starting around Amarillo and the Texas stovepipe there, and then moving to the southeast in about 3 days. Some very strong storms there on the GFS model. And let's check precipitation totals. You could get as much as like 4 or 5 inches of rain there in the Texas stovepipe. Also, Florida expecting some areas with over 5 inches of rain. That's your GFS 72-hour total accumulated precipitation in inches forecast. Next, we've got a lightning mapper, and there's been a heavy lightning around the Caribbean and Central America. Also, the central U.S. seeing some significant lightning strikes. Let's check a real-time lightning map to see what's going on. Do we have terrestrial strikes in the U.S.? Well, it looks like there are 2 different thunderstorms happening. One in eastern Kansas and one south of Amarillo. Some lightning west of Amarillo, too, but the main cell is actually east of Amarillo. There you can see thunder rolling in. And let's check this storm in Kansas. Right around Topeka there. And here's the full view. It looks like also some Iowan lightning happening there. The Mediterranean, the current lightning capital of the planet, it looks like. Quite a bit of lightning there around, especially the northern portion of the Mediterranean. Looks like another bad day to attempt to immigrate to Europe. We'll close out the video with U.S. Doppler radar, clouds and fog, and the water vapor map. There's the full 50-state view. We'll fixate on the lower 48 view. You're going to see some errors here in these other maps, so prepare yourself. There is the water vapor map, and it's showing a really long time frame. Let's shorten this one up as well to 10 frames. Here's water vapor, also depicting a really long time frame. Rapid cloud nucleation happening there in the Rockies. It must have been a signature day for hot air coming out of Colorado. America's hot air source. The official capital of hot air in the U.S. Anyway, there's the water vapor map. Here's a recap showing U.S. Doppler radar. That's vertical motion of water and ice crystals in the air column, by the way, from ground-based Doppler radar systems. These are space-based systems, and those errors are caused by space weather. That's clouds and fog depicted by shortwave radiation, part of the infrared spectrum. And that is water vapor, a different part of the infrared spectrum, 6.19 micrometers. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. If you'd be so kind as to press like, subscribe, share, etc., we'd be much obliged. Also, don't forget to visit our links and increase the probability these videos will continue to exist, remain publicly visible and free for all to view. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And I am headed back to the bunker. Bunker, make me safe. Here I come. Woo!